So let's begin with the day 5, I guess. Luke is a foodie. Luke likes to eat. There are n piles of food aligned in a straight line in front of him. The ith pile contains AI units of food. Luke will walk from first pile towards the nth pile, and he wants to eat every pile of food without walking back. When Luke reaches the ith pile, he can eat that pile if and only if v minus AI less than equal to x, where x is a fixed integer and v is Luke's food affinity. Okay, Luke will walk from home and he wants to eat every pile of food without Luke reaches that pile. He can eat that pile. Okay, definitely. Before Luke starts to walk, he can set V to any integer. Also, for each I, Luke can change his food affinity to any integer before he hits the ith pile. V is food affinity. X is fixed integer. Okay. For each I also we can change the food affinity to an integer before he hits the ith pile. Find the minimum number of changes he needed to eat every pile of food. Note that the initial choice for V is not considered as a change. Input consists of multiple test cases. The first test case contains a single integer t. Okay. N x and number of piles, maximum difference between size of pile and looks further than look and eat pile. Second line contains an integer and number of changes needed. Now, for the first test case, look and set V to 5. What do we input? Output is the minimum number of changes needed. Okay. Well, this looks an easy question. First test case, look and set V to 5 before on state without changing V. N and X. He can set V to 5. Okay, well, it's minimum number of changes. Since the element increase and decrease, the minimum number of changes, there will be changes for sure. Let's say if a array was going on decreasing, then there will be zero changes always. But since here it increases, then further it decreases, then we need to implement a change. If you look here, 3 minus 8, 8 minus 5, 5 minus 6, 6 minus 7. Just we need to find the difference of consecutive elements. 3, 8, 5, 6, 7. 3 minus 8 is 5. 8 minus 5 is 8 minus 5 is 3. I mean the absolute difference. If you look it's 1. So the difference goes on decreasing. Then it will be a good thing. 3, 10, 9, 8, 7. 3 minus 10 is 7. 1, 1 and 1. Here also it goes on decreasing. Okay, we have x as well, x equals to 3. V minus ai less than equal to x. If we solve the inequality, so this is what we get. Hmm. Now let's begin with first test case 3, 8, 5, 6, 7. And x is equal to 3. Now there are limits on v, but I think there should be also limits on, okay, ai plus x is 6 and ai minus x is 0. We should be between 0 and 6. So this will be maximum limit and this will be minimum limit. If we go here, then the maximum limit will change to 8 minus 3, 5, and minimum limit will change to 8 plus 3, 11. And similarly so on if you go on doing. In the second test case, Luke can set v equals to 3 before starts to walk, and he could change v to 10 before he hits second pile. After that he can walk straight to eat remaining food. Mm, Fifth test case, we do 4 and could change before he hits the fourth pile. 7 pile can set without changing v. This is the constraints on v to aid this AI, and these are the constraints on this thing to aid this thing. Well, it's easy. I got it. I'll explain by taking the second test case. We have 398, 310, 987. What I'll do is I'll create a pair of int command where I'll be storing the minimum value and maximum value we can take. Now, what is the minimum value we can take is x equals to 3, 0 to v2, 6. What is, I mean, 6 plus 3. No, no, not 6 plus 3, 3 plus 3 and 6. So we can take this. Now, what will we take in this thing? In first iteration, this is the second iteration. We can go from 7 to 13, and in the second iteration we can go from 12 to 6, and in third iteration we can go from 1 to 3. Yeah, I guess it's the fourth iteration. 8 plus 3 is 11, 8 minus 3 is 5, and the fifth iteration, 7 plus 3 is 10, 7 minus 3 is 4. 1, 2, 3, 4, 5, yeah. These are all constants on V. Now what I'll just simply check is, you have to play with the here values. If this higher value of the previous one is less than the higher value of the current one, then we need one change. We'll just implement the value of, I mean increment the value of change. Now V can be between 7 and 13. Also there will be some other constraint on the lower value as well. Higher value less than equal to lower value of current, then we'll be reading a change. As we can see in this case, 6 is less than 7, so then we'll obviously need a change. Now if we look at this, V is between 7 and 13, and it's between 6 and 12. So 13 is higher value of this thing is greater than 6. So the work can be done. I mean, it's possible for me. See, if it is 13, I think this doesn't matter for me now, because then it will be set to 8. Then what will happen? The higher value of will be sent to lower. I think that's it. I mean, let's check for other iterations as well. 12 is less than 5. No, we don't need one. And 11 is less than 4. No, we don't need any change. Yeah, I guess that's how things work. We'll try implementing it. If it fails, then no problem. Just change our idea. have the array with me. Low current equal to 0. If high less than low current, high previous less than low current, and what we'll do is simply increment the change. Mhm. Okay, it failed on the third test case itself. Let's check on that. The fourth test case also failed. Hmm. Uh, if we see the third test case, "25, 3, 3, 17, 8, 6, 1, 16, 15, 25, 17, 23. Hmm. Now, in the first iteration, limits on v will be x is 8. Hmm. X is 8. In first iteration, 25 minus 8 is 17 less than equal to v less than equal to 25 plus 8 is 33, and then second iteration 3 minus 8 is 3 minus 8 minus 5, v less than equal to 3 plus 8 is 11. Third iteration 3 plus 8 is 11 and it's minus 5. Fourth iteration 17, 17 plus 8 is 17 plus 8 25, 17 minus 8 is 9. In fifth iteration v is between, like, I need to write it manually, I guess there's no other option, 0 to 16. Sixth iteration v is between minus 2 to 14. And seventh iteration v is between 9 to 1 minus 8 minus 7. And in eighth iteration v is between 16 plus 8 24 and 16 minus 8 8. And ninth iteration, how many elements are there, by the way? Oh, 12 elements are there. 15 plus 8 is 23, 15 minus 8 is 7. And in 10th iteration 25 plus 8 33, 25 minus 8 17. 11th iteration, 17 minus 8 is 9, 17 plus 8 is 25. 12th iteration, 23 minus 8 and 23 plus 8 is 31, and 23 minus 8 is 15. Well, if I apply my logic, 33 ways between 17 and 33. We need a change over here. Why do we need? Because it is between 17 and 33 and v is between 17 and 11, so it cannot happen. This should be less than this thing. If 17 is greater than 11, then also we'll be having a problem. Moreover, I forgot to update here earlier. Update the values. 17 greater than 11. I'll just write it. 17 11. Low previous HC. P greater than X. Zero 1 1. Okay, okay, okay. 3 4. 4 test case and this test case also we got wrong. And in the third test case, there is one more change which we require. If I go according to my code, then ways between 17 and 33, ways between 11 and 5 minus 5 and 11. So it's not possible, we need one change. And this is possible, no need of any change. 9 and 25. This is also possible, no need of any change. Let's say we take V as 10, then it's good to go. This is also possible if I continue with 10. This is also possible if I continue with 10. This is not possible if I continue with 10. And also LP, HP, LC, HC. Lower previous LP is greater than HC. No. And HP is less than LC. No, no. Minus 7 to 9, minus 2 to 14. Here we have 10. Here also I took 10, let's say. One minute. So I'm back. So the thing what I was thinking is, what we can do is, if the condition is not being obeyed, I mean, suppose I will just explain in the code. If this thing doesn't happen, let's say, I'll increment C by 1. Also, I'll set HP as this thing and LP as this thing. Higher previous value and lower previous value. Else I'll set higher previous value as so. But for this thing, what I'll do is what I'll do try doing is set the highest bound for on left side for this thing and lowest on this side, so that I could just get the intersection. LC will be this thing, that's okay, and HP will be HP will be maximum of LC comma LP means lower previous. This will be maximum of this comma this LC comma no lowest previous comma lowest current, and HP will be maximum of highest previous comma highest current, and so on. Let's try doing this. Again I got the same error. You have to find the minimum number of changes needed to hit every pile of code. Initial choice of v is not considered as change. He can set v to any integer before he hits the ith pile. So firstly I'll set v as something integer between this 0 and 6. Basically there will be two possibilities. Firstly I'll start with some initial value of v between 0 and 6. Then for 8 what I'll do is let's say I take it as 0. Now for 8 what I'll do, if v is between 11 and 5, then I will not do anything else. If it's between this thing, that's what the thing means, that mod of v minus ai less than equal to x. If this thing is not obeyed, then what can we do is we'll just update v. We'll set v as 11, let's say. 3, 10, 9, 8, 7. Here we need a here we require one change. 5 comma 3. We have to select some value of v and then check for this thing, then check for this thing, check for this thing, check for this thing. How do we do it? For this thing we can take v between 0 and 6, and for this number we can take v between 7 and 13. For this number I'll take v between 6 and 12. For this number I'll take v between 8 plus 3 is 11, 11 and 5. For this number I have to take v between 10 and 4. Now what will I do is I can choose v between anything. I think my previous solution should have worked. I made some error somewhere. 0, 1, 2. Let's try comparing our code. I mean, just checking and verifying how does it bring me to the wrong answer. Let's say we have this thing. Now, firstly, I'll set HP as A0 plus X and LP as A0 minus X. So first of all, my HP will be this 33 and LP will be 17. Now what I'll do is LC equals to A minus X and LC, and this is HC. If HP less than LC or LP greater than HC, means HP is less than LC. That's not happening here. Or LP greater than HC. Lower previous greater than HC. What I'm saying is if I choose a number between minus 5 and 11, let's say I have taken 6, then 6 does not fall into this category. If I've taken 18, 18 does not fall into this category. So I have to compare between LP and HC. LP is greater than HC and HP is less than LC. It's so complicated to think about. Okay, let's direct zeros. HP, this is HP and this is LP. This is HC and this is LC. Now HP is less than LC. No. We'll compare both of these things. I mean, if HP is greater than LP and LC and LC is less than LP, that's where the brute force come here. I think there will be certain cases where we cannot choose the numbers. Let's say we have two numbers x1 v and this is x2, or let's say y2. This is the upper y1, I mean, and this is x2 v and this is y2. Oh, the v is same here. I'll just I got or like I mean I got some cases where there will be several cases where it won't happen. X1 v less than x2, y1 v less than equal to y2, or let's say this is x2. I'll rewrite it again. Sorry, v less than equal to y1, x2 v less than equal to y2. Now what can be the cases? We'll have four cases over here. So we'll be getting four cases over here, I guess. So x1 less than x2 and y1 less than y2, x1 greater than x2 and y1 less than y2, x1 less than x2, y1 greater than y2, x1 greater than x2 and y1 less than y2. These are the four cases and we'll respectively solve for these cases. Now if this is a scenario, let's say x1 less than x2 and y1 less than y2, then x1 and y1 is two values. Let's say x1 is less than x2 and y1 is less than y2, then there will always exist a value, then we are good to go. And now x1 greater than x2, yes, I'm back. The thing was that we need to find here overlapping, no, wait. Yeah, we'll just we'll find the current intervals. We'll denote L as the thing which I did here was I'll be taking lower limit as this thing and upper limit as this thing. I don't think we need this all. Actually, the logic is, let's say this is L and R, or else it will be, what we'll be doing is we'll be finding the overlapping intervals. Now between 17 and 33 and minus 5 and 11 there are no overlapping intervals. We'll leave it. Let's say minus 5 to 11 and 9 to 25. We'll check for overlapping interval by taking maximum of this thing, the lower intervals of each, and the minimum of this higher intervals of these. So that we'll get overlapping intervals. If this thing LP is greater than HP, then I'll just add the moves and that's it. I'll start again now. Since I cannot go, I have to move only forward for eating the foods. So I just have to start again new over with the current requirement of V within the array. So let LB as AI minus X and HP as AI plus X, and that's it. Now we'll just print the number of moves. Yeah, it got passed. I'll explain it again with the help of a simple test case. So the condition is AI minus X less than equal to V less than equal to AI plus X. Now let let's have taken the second test case. 3, 10, 9, 8, 7. For this thing, AI should be between 0 and V and 6. For this thing, AI should be between 7 and 13, because 10 minus 3, X is 3 here, that's why. So 10 minus 3 is 7, 10 plus 3. And then 9 minus 3 is 6 and 12. And then 8 minus 3 is 5 and 8 plus 3 is 11. And so on. 7 plus 3 10 and 7 minus 3 4. Now what will I do is I'll find the common interval. So here we'll be having common interval because it will be the common interval will be maximum of these both, comma minimum of these both. Wait, 0 to 6 and yeah, 7 to 6. So here this is L and this is R, or LP RP. Here LP exceeds RP. LP exceeds RP, so I will means I won't be able to eat the food. I need to make changes to V here. So what I'll do, I'll just simply set V something between 0 and 13, 7 and 13, and my LP and RP will continue to be 7 and 13 rather than being 0 and 6. It'll change to 7 and 13. Now this 7 and 13 will satisfy this both. Now our range will be maximum of these both, which is 7, and minimum of these both, which will be 12. Now this thing 7 and 12, and 7 is not greater than 12, so this goes on continuing, hence there will be no requirement of change. The thing is that we need we need the change only when the intervals don't overlap with each other. That is the thing. If I show it on number line, then 0 and 6 will come somewhere like this, and 7 and 13 will go somewhere like this. So they don't overlap here. And if we check our like overlapping range, if we go for our overlapping range, and if we find just maximum of these both, this will be this thing, and minimum of these both will be 6, and say L cannot be greater than R. But if you look at these both, 7 and 13 and 6 and 12, 6 and 12, so L will be this thing and R will be this thing. The minimum of L R will be minimum of these both, 13 and 12, which is nothing but 12. I mean, I'll draw this second thing again and show you. This is the number line, and somewhere we have 7 and somewhere we have 13, and somewhere we have 12 and somewhere we have 6. This interval is perfectly fine for us because we select this both maximum of 6 and 7 and minimum of 7 and 12. This will be our overlapping interval, so our v value will be satisfied. Similarly, it goes on for 5 and 11. 5 and 11, then we'll get overlapping interval, and similarly for 4 and 10 we are done. But here 0 and 6, they were not overlapping, that's why we had to increment the value of count. So we the value of answer, so that we needed to change the value, we needed the change in value of v, and we continued with the old values. Actually, I thought of this idea, but my doubt was that what if like it would be possible if I just go, some values might satisfy this thing, and then I'll directly jump to this thing and I could eat this food, and then I'll turn back and I'll make some change and I'll eat this. But actually the question was mentioned that changes food affinity to any integer. Look can changes. He does not he does not go backwards without walking back. This is the main condition. So that was why it didn't work. Yeah, now I think this code might work now. Okay, fine, it's done. So yeah, that's it for today. I was able to solve only one question. We'll meet tomorrow. I'll try to solve two questions. Bye.